introduce myself from the University of Oslo. So we have 5 interesting talks to look forward to. So I suggest we just get started with the first one. So the first presenter is Yuji from the University of Okinawa. Is that right?
Yeah.
Mm-hmm. And he will present work titled Evolution of Rewards for Food and Motor Action by Simulating Birth and Death. Please go ahead, Yuji.
Yeah. Yeah, thank you for coming. And if you are, I'm usually from East Japan. And if you're curious, if you're feel boring, please open the demonstration. Please open the demonstration website where you can watch some of my agents are moving and here. Let me start. So first of all, so I want to ask, so maybe it's weird in the community, but I'm from like a neuroscience lab, and some of my lab mates are working on the like hardcore neuroscience using mice or some, but only me is doing something weird stuff. So first of all, I want to ask you what do you think is the like most important brain function? So the brain can do like many things, like they can make decisions, they can plan, and they can keep homeostasis, like by feeling sleepy or something. But what do you think is the most important? So some people are like, I want to like know all of yours answer, but to answer my text, I think that the reward system is like most important one. So what is the reward system? And the reward system is like the system in your brain that feels something like a pleasure and like drives some learning to get more pleasure or pleasant things, and like the induce the like behavioral strategy as a result of learning, and it works as a motivation. So that is all about the reward system. And I think that this is like really important for us and animals because so being intelligent is like maybe important, but being intelligent does not make me happy, but eating something and feeling food pleasure like it really makes me happy. So I think, and for LF people, like I prepared this slide, and I think that the reward matters in life because it's one of the simplest way to implement the aim for like agents. Yeah. So simply you can think of the reward function as like mapping from like all sensor events to the like one scala. So it just like judges like what is good or what is bad for us, like in their innate manner. So like this is that there is like any other simple way to implement the M or agents in agents. So if you don't agree, so please come to me after the presentation, and maybe we can have a very long discussions about these topics. And my question in the research is that why this kind of the reward systems have evolved. So yes, we all know that all of our body systems are the result of the evolutions and the natural selections. But actually, so we have like a variety of reward systems. For example, how can I move this? The variety of reward systems like food rewards and fatigue and fear and social rewards, and we have like a variety of like reward systems in your brain. So we know that all of these are like the result of the evolution, but we don't know like what caused the evolution of this each reward functions, for example. So maybe it's like very basic reward functions like food reward or fear can be like can already exist in the early vertebrates, like all the fishes, and maybe the social reward, maybe the more complex one like social reward, like how evolved later. But we don't actually know like what caused the evolution of what. So this is why like I think that simulation matters, and by like by simulating the evolutions of rewards in like several environmental conditions, I think that we can rebuild the like, causality. So what kind of environment or what kind of situation causes evolutions of these rewards? Okay, so like let me explain a bit about our methods. So like this. Let me explain about my simulation model first. So this is actually a bit complex, but you can simply understand that it's just to reveal the nature. So it's just imitates the way that nature is. So I just prepare the environment with just many agents and also many foods, and each agent has their innate reward functions. So their reward function is encoded by genes, and they can't change it by running. And throughout their lifetime, so they learn their behavior by reinforcement learning. And they can make children by asexual reproduction when they have enough mutations, and they can die because of the age and the hunger. So that's it. So it's just a like system with many agents with birth and death rules, but they can inherit some reward functions, and they can learn through their reinforcement learning during their lifetimes. So this is the actual implementations of the environment. So this blue circle is like agents, and these red circles are food, and they have like some touch sensors around their front, and I implement a very simple metabolic systems to them, so that is they can gain one energy by eating one food, and they are consuming some energy by moving, and some basic energy consumption. So that's it, and because this is like actual implementation of the environment, and this really works fast because thanks to the like current technologies like GPU and JAX, and check out my like physics simulation implementation if you're curious. That is so, and let me explain about the reward and the model of the reward and the learning. So in the real world or real animals, so there are like many events that can be rewarded, but to make this experiment more interpretable, so I limit the source of rewards into like two events. One is the food intake, and one is like exercise. So this so in the reward function is the sum of two factors. The first factor is the reward for food intake, and the second one is the reward for like taking motor actions. And the rate of these two reward factors are like evolvable, and they evolve by mutations. And as a model of learning, so I prepare a 3-layer material perceptor, and they run by some reinforcement learning algorithms in this time, I mean PPO, and the behavior model takes sensor, velocity, angle, energy, such information, and just outputs the motor output to the left and right of their bodies. So it's taking too much. And the model of birth and death is also very simple in the simulation. So, but both are just a probabilistic model, and the birth model just depends on their energy. So it's just a model that if they have more energy, they can they have more chance to get their children. And the death probability is also very simple. So maybe it's better to see this figure. So this is survival. This is survival probability for one agent. So it means that if the agent has less energy, so they will die very quickly. But they will. But if they have enough energy, so they can live up to around 1 million steps. Okay. And so let me show the result of the simulation. So I did experiments with 10 million steps, so it's just a convenient number for me. And throughout the simulation, the population size is around from 100 to 200, and it injects about 1,000 generations, and totally 200,000 of individuals were born in total. And I did run 5 in each experiment, so I did run with 5 random shifts. So this is evolutions of rewards over the steps, and maybe it's better to see the last populations here, and but maybe you can see that it's actually very unstable. And in the last population, so I found that there's a tendency that they have 2 groups of the reward function. So the reward for food is always positive if it's these 2 groups, but the reward for taking an action is sometimes very high. It means that they really like to move around. But in the other groups, the reward for taking action is slightly negative. It means that they don't like exercise, and they just prefer that to stay there without moving too much. This is a interesting finding, because I expected that all agents. I expected that all agents have the negative action reward, because animals have the sense of fatigue. So if we do lots of exercises, we do fatigue, and we don't like the sense of fatigue, because it consumes their energies, and it can be not good for our lives. So this is surprising. But then I compare the reward function, the above reward function, with the different environmental sizes. So in the with different food densities. So what I found is that in the small environment, which is with too dense food, so with too dense food, so the food reward is a bit evolved towards the positive direction, but no evolution for action rewards. So making the environment large and making the food distribution a bit sparse. makes the action rewards a bit smaller, but it does not have a very big effect. But so maybe this is a most important finding here. But and then I tried to evolve the rewards with different food distribution. So in the previous figure, the food is generated uniformly random locations, anywhere in the environment. But here I limit the distribution of food. In this case, the center environment, so the food is always generated around the center of the environment. And in this case, actually there no selection pressure I observed, and no evolution happens. So it's just looks like a result of the random walk. Because I think this is because in this environment, so the quality of reward where they born is more important, and what kind of reward function they have is not very important. So they just need to born. They just need to be born around the center of the environment, and that's okay. That's enough, and they can survive. But in this relocation setting where the food is generated in a very vast way, but the food location is moving in clockwise after 1,000 food is eaten. So in this case, we can we could observe the shift of reward functions. So in this case, the action reward is almost always negative. So yes, maybe only in this setting, so I observe the evolution of fatigue constantly. Okay, so it's almost over. So let me skip the result about the poisons and poor food. So this is actually not very going well, and they sometimes poison the result shows, and I really don't know why they sometimes poison. It's I need more analysis. Okay, so let me summarize. So the conclusion is that food rewards are always positive and very easy to evolve, except too easy dense environment. But action rewards is more unstable, and this can be positive or negative in the uniform food setting where they can get food by just randomly moving around. But in the setting where the food is generated in a biased way and it's moving, so we could observe the evolution of the reward like fatigue, which is a negative reward for the taking motor actions. And maybe I need more works to analysis and introducing the predator persistence and also sexual reproduction or something. Okay, so that's all, and thank you for listening.
Thank you very much. Questions?